So our primary mission here is satellite validation, right? So we just launched this next generation system, and in order to validate its performance independently, we've got our aircraft sensor with well-calibrated instruments, and we use that to give us high confidence. So we're flying really high in the atmosphere, and it gives us very good comparisons to what the satellite's seeing.
Today we're doing a mission, wheels up from Warner Robins, Georgia Air Force Base at 1700.
We do have another long-wave trough beginning to approach the west coast later in the period by day 7, indicating that the wave train is back.
So the go, no-go decision is 100% dependent, of course, from day to day on each mission. Today, what we decided, the reason we're a go is because we're in Huntsville and we have a very long loiter time over this location, and we have an LMA and a pretty intense instrument network here that we can, even though the case itself is not great, we're not expecting a ton of lightning with these systems, we can still get some really good data out of it.
Sounds like the mission's a go. Any instrument keeps spinning? Question?
We coordinated ABI, special scans, 30-second imagery, 17 Zulu to 22:30 Zulu today.
We're getting a little bit of what's called potential energy. We call it convective potential energy, and it's helping fire up some of these storms. And so this is what the models were kind of picking up on earlier. We call it convective initiation. And so that's what today's mission is really geared toward.
Yeah, I got the Cirrus satellite, the visible, and then I've got CPL that shows.
The GLM, the Geostationary Lightning Mapper instrument itself is an optical instrument, and we have virtually no other optical measurement to corroborate what the GLM is seeing, except for an instrument that we've developed for the airplane. And so we're looking down on cloud top at lightning.
Some things that we've shown is that if you're able to incorporate lightning into a forecasting environment, we can do things like increase lead time before severe weather hits, decrease false alarm rates, so we're able to forecast severe weather a lot better, which of course means time and maybe more importantly, saving lives.
So we don't know where the lightning originated. So the GLM is giving us where the flashes are beginning and where they're propagating, and then with the ground-based you can tell where they went to ground. So if you're, say, at an airport, baggage handling, fueling, you're outdoors, you may not realize that you have a non-zero risk above you with the lightning propagating overhead or coming from some distance away. And so the GLM can help us to pick that and improve your situational awareness.
But then what you do is click here.
The data coming from this system is just phenomenal. We are seeing data at 3 times the data rate, double the resolution typically, and it's just meteorologically, we are seeing features that we have never necessarily noticed before on the longer lagged data from the previous satellite systems.
The advantage of having a high altitude aircraft is that we can make, as best we can, a measurement that mimics what the satellite is seeing.
We're at 70,000 feet. Your typical airliner is down around 35,000 feet. So if we sit here on the ground and we see an airliner way up high making a contrail, we look down from the U-2 almost at the same distance and see those airliners well below us making contrails. So we're twice as high as an airliner.
So what this is going to enable people to do is just see mesoscale features that we really didn't have a good handle on. Right. And that's why having again the aircraft in place, it allows us to get deeper insights into this phenomenology that's again kind of new to us because we've never been able to stare at the Earth at this resolution.
Right? Photo player.
flying really high in the stratosphere, 20 kilometers, what that enables us to do is overfly a target of interest and match the view geometry of the satellite. And it gives us very high confidence that we're collecting, what the satellite is seeing.